the technical. So the topic of my talk is on AI for AI, on using uh, artificial intelligence technologies to control avian influenza outbreaks. By default, I'm a computer science. I mean, I'm a computer scientist. My background is artificial intelligence, and but also I work on technology governance. But being at University of Guelph, I apply my research to agriculture and food. And next slide. My research program combines artificial intelligence with data and technology governance. Um, I'm not quite familiar with the audience and how technical, tech savvy some of our audience members are. But as you know, artificial intelligence is a technology that uses data whether collected from sensors or collected from computers or entered by human to a system, to a digital system, and it uses that information for decision making. Some of the artificial intelligence methods are traditional ones. They look at very simple mathematical calculations. And some of the more sophisticated ones that probably you're familiar with, which is ChatGPT and large language models, they have been built, in the past 20, 25 years with the idea of replicating human brain and how it functions. So basically, considering nodes and neurons and then how those entities in the artificial intelligence communicate. So those are a little bit or a lot more sophisticated. They're harder to train and it takes a longer time to train. But like human brain, as we remember and we learn from our environment, these type of technologies also learn from the environment. And that's why we have generative AI methods such as ChatGPT that can learn historical data information and generate new content. So that's probably an artificial intelligence algorithm that has become mainstream. We use artificial intelligence every day. It's on our mobile, it's on our computers, in the back end, and we don't know what, we interact with it every day. But ChatGPT has become mainstream in terms of it has become our friend and colleague these days. So that's artificial. So my research covers all of those. Just we use it the best ones for the applications in hand. The governance aspect covers topics such as data sharing, privacy, security to some extent, and also ensuring these days that the data collection and use is ethical. And the ethical aspect of artificial intelligence that brings social, legal, and other aspects to the whole discussion around artificial intelligence. Next slide. There's an animation. Yeah. So I use my research to agriculture and food. As you know, data is being collected from in this sector from farm to fork. From sensors that collect data from farms all the way to grocery stores and retailers where consumers buy items, scan, and then packaging and everything. Data is being collected. And next slide. Before I go to my actual presentation, I just wanted to say that this is credit not. I'm one of the members in the team. I'm a computer scientist. You may wonder how computer scientists is working on disease modeling. It's because of my colleagues, Dr. Sharon Sharif, Zavonimir Polyak, and the entire team. Some of them have background in immunology. Some of them have background in epidemiology, and some of them are computer scientists. Basically, this is a very interdisciplinary research program. Next slide. So we have experience, and you're the subject matter experts when it comes to avian influenza, I believe, some of you, but basically the concept is quite similar to COVID. When an outbreak happens, health officials, Canadian Food Inspection Agency, they have to make some decisions. And now potentially some of the farm associations and producers, maybe there will be an expectation or they may be interested to monitor the disease outbreak and make some decisions. So this decision making comes with digital decision support tools that are heavily based on high quality data. And this high quality data is being collected, I mean, depending on the objectives, which I go over some of them very quickly, from different sources. It could be from the internet or FAO, what data has become available, CFIA, the data they collect. As you know, it's the reportable disease from the farmers through reports. And that data all gets collected in kind of distributed, each organization, and Wildbird as well. Data, it gets collected in different sources, and basically if we collect them, pre-process them, clean that data to create high quality database, then we can use it for decision making. So decision making, there are many different objectives at high level. First of all, we want to be able to identify an outbreak in a region early, because benefit of that would be organizations such as CFIA and maybe even farm associations. They can make proactive decision in terms of how to implement some control measures. And also, we can identify high-risk population, maybe farms, and within an area, within the timeline. And also, we can identify what risk factors maybe for that outbreak, given the type of subtype of virus, has contributed to that outbreak. And again, making informed decisions. So if it is one of those subtypes that are not deadly, maybe the type of decision we make, or maybe in France, and now I've heard US, they have started vaccination as well, then they can decide whether vaccination would be needed given the type of the virus. Prediction of risk and what can go wrong and how many farms could be impacted. It would be good for monitoring and also optimizing the response to outbreak by the emergency responders and whoever is responsible for controlling outbreak. The next, yeah. So the objective of our research is, so you might think, okay, so the data is available, why can't we use it? One of
No, Rosita, it went quiet. Oh, there.
And my colleagues, yeah, I don't know, maybe, yeah, so maybe it was on my side. And my colleagues used to refer to this as garbage in, garbage out, meaning if the data is low quality and we feed it to an AI system, then the output is also not reliable. So data is absolutely fundamental. We spend, especially because artificial intelligence algorithms have advanced quite a bit. And also the infrastructure has also advanced, but data aspect is still fragmented. Data is low quality. Some of the data that is being collected, they are not useful for decision making. So there are still lots of challenges associated with the data that's available. So quite a bit of our time is spent on cleaning data. But at the time of an outbreak, when an outbreak happens, you cannot wait for 4 months to collect data and then clean it and bring, basically one of our objectives is to identify important data sources and attributes. And when I say attributes, for example, how much farm density in an area contributes to decision making for about severity or risk of an outbreak. So not only the data, but data attributes, collecting, pre-processing, and creating high quality data, hopefully in real time or near real time. When I say hopefully, because for now, for avian influenza, we cannot collect data in real time. But if in the future, let's say in 5 years, we can collect data in real time, we will be in a great position. And so basically identifying the right data attributes, collecting them, making them available for analysis, analyzing and understanding what models will help with decision making. And at the last step, how useful, and this is what makes our research program unique. We are building these surveillance tools, these decision tools for the end users, which could be, again, emergency responders or immunologists, epidemiologists, then involving them within the development process to understand what their needs are. So we did an initial study 7 years ago. So collect that information. And so we switched to big data and open data. We collected social media data, Twitter at that time. Now we have Google search data. You know, when you search on Google, all that information gets collected, and there are ways for us to collect that information. Reddit and other news feeds. We thought maybe like COVID, this is a research that has been going on by Google and several other tech giants. Can we predict an outbreak with social media data? So that was one aspect. The other aspect was spatial temporal data that we collected from different sources, FAO, WHO. And spatial temporal is you have the location and you have the time with that data. So it's the weather on this day, and this location that makes it spatial temporal, or an outbreak of a wild bird has been observed in this area on that day, so that makes it spatial temporal. So we have collected that information. At that time, we couldn't collect farm data because there was an outbreak. So they're making a justification for collection of farm data. I mean, farm data, CFIA gave us farm data, but I mean, on-farm data, maybe videos, and now we are in discussion to find out if we can collect that information, animal movement and those sort of things. So we combine that data, kind of the combination using different use of AI algorithm, because, for example, for text, for Twitter, we apply large language model methods. But for spatial temporal data, which are some of the numerical data, we use more simple or statistical or artificial intelligence method. So with that initial study for building a decision support, not actually a system, but a framework, we showed that social media, next slide. Social media can be used for, and if you click again, I think the result is also social media can predict 75%. That's 2017. Since then, many more farmers are using Twitter. Many more farmers are available. They're active online. And information may be included in that data. It takes quite a bit an effort to clean text data. It's one of the hardest ones. But once you clean it, based on the keywords and key phrases, we look at activity in a region. Maybe people are asking questions from Google or from Dr. Google, or maybe they are, posting topics on Twitter or other media outlets, online media outlets. And we collected that information and extracted clean information, extracted the date, and we realized we can, within 3 to 2 weeks, we can predict an outbreak. There's some abnormal activity in a region, which could be a useful tool for emergency responders to constantly monitor and make decisions, at least to investigate what's going on in a region if a topic is being discussed a lot. And also, for next slide, for the spatial temporal data, we focused on Indonesia at that time, mainly because Canada, there wasn't that much data available. At that time, we were interested in wild bird data, which again wasn't available because we found a website at that time. They were reporting it was a citizen science project. People were reporting observing birds. and then they would the creator of that website, I mean the people who were managing it, they will categorize whether it's wild bird or not. So that was the only information available. That information was available about Indonesia. Indonesia was collecting quite a bit of they were reporting, outbreaks quite frequently, because some other countries they do not report, so that data is not available. They used to be one of the top users of Twitter. So basically, data was available in Indonesia. So we focus on that. Again, we were able to show with spatial temporal data, as I mentioned, data that has location and time. We were able to show that we can, predict presence of an outbreak in a region, 82% accuracy, using some of the data we were able to collect, weather, wild bird, and additional information. Chicken duck density, so that's that. And then we thought, okay, so this is a decision support framework, but one of our goals was to build a system, because framework, again, is not that accessible in a real time or near real time as we want. So we build a decision support system. So decision support systems are tools that you collect data from different sources, clean them, all that, everything that you can perform on that, on the data, you make it available for decision making. Then from that, you create different models, and then there is a dashboard that can be used for decision making. That can be used by the end users to make decisions. Next slide. Yeah, so this was a very simple decision support system. As you can see, it shows the location. Rachel, these all have animation, so I apologize in advance. But we started the phase 2 of the project, especially with the recent outbreak since 2022. And this time I decided to bring the governance aspect to the project as well. And you can click on all of them. And the governance aspect, so we are building these tools, we were hoping that we can collect farmers' data. And as soon as you enter, so for a fun research project, that's perfectly fine. We published 2 papers and we could have moved on. But I decided that we want to make this tool useful for the end users. And one of the challenges of AI tools in agriculture, maybe slow adoption, or kind of low interest, aside from cost, and I know there are other challenges, but one of them is a trust. um, why should I share my data? What kind of data you need from me? What does anonymizing and de-identifying data mean? Because we claim that we do all of that, and we do. And even Canadian Food Inspection anonymizes data and creates synthetic data, so it doesn't give away raw data. And also, and also understanding what emergency responders really need, because using very sophisticated AI algorithms, it's a fun project for my students, but that doesn't necessarily mean the decision makers need that type of model, or it's helpful to them. So we brought all different aspects into this project, and our idea was we have to embed um, all of these into the system rather than dealing with it after the fact. So we wanted to build a tool that considers farmers' concern around data sharing and data collection, anonymizes and data properly, and so all other considerations that had to go into building these tools. So we started building the system. I mean, the basic system that you saw in the previous slide, we started advancing it. We added very kind of sophisticated dashboard. And then also we focus on Canada. We can go to the next slide. Yeah. So in order to understand what the end users really need, and also the people who share data, whether they feel comfortable uh, with what we are collecting and how we are using, um, we started engaging the end users and stakeholders into the process. So, for example, we have had kind of a focus group with CFIA. We have engaged epidemiologists at the University of Guelph to give us feedback. So we have had few questions on, this is the type of data we have access to. This is the type of prototype of the dashboard, with metrics and visualization. And so we started doing engaging some of the stakeholders. We have also engaged some of the producers, and they have also shown interest to share data. So apparently, with the recent continuous outbreak, the willingness to share data has increased, which is great. We haven't yet showed the decision support system to producers, but that's our plan. And also, we have engaged them in the discussion around privacy. Privacy is a concern, not as much as it was in 2017. That's also because of the threat avian influenza has brought and challenges. So we started engaging them throughout the basically research lifecycle. So maybe if you click the animation, I'll show. Yeah. So 3 times. Yeah. So we started very small. We spoke with CFIA. We collected some data for descriptive analysis. Descriptive analysis is that what's currently going on or what was used to go on maybe 2 months ago, a year ago. And then we visualize that data, we show it to them. Then we started on predictive analytics. We looked at many papers. We looked at many existing dashboards, especially Europe has been quite active. We brought that into our work that we are currently doing. My team, on the ones that are focused on privacy and security, they are privacy, sorry, and confidentiality. They are also looking at privacy enhancing methods and the confidentiality enhancing methods to aggregate data, anonymize data, and so through that, so we are bringing everybody and all different skills and expertise and engaging the end users to get feedback on what we are building and whether what we are doing is useful and also whether it's trustworthy. Next slide. So yeah, and then we focus on the actual decision support system. So decision support system has different modules. This becomes too technical. We can skip this slide, but it has a user interface, which we didn't have in the previous work that we did. Next slide. Thank you. And one of the things, one of the hardest time-consuming work that we did on this was, previously we only used few data sources. Then we thought we have to expand it because now we are putting the resource. I have several PhD students and a master's student who is working on this. And then PhD students, some of them are working on governance. Those are additional students. But we thought, okay, we want our data to be as comprehensive as possible, but for Canada this time. Because of these outbreaks, more data has become available, high quality data. CFI is working tirelessly to collect that information, all as well as eBird and some of the other colleagues that are ECCC, kind of environmental. So one of the government organizations, and also Animal Health Canada. So everybody is paying attention to this. So the more data is becoming available. We want to know about human population around the area of an outbreak. We want to know about land cover, number of roads around farms. We want to know about the type of farms because I'm not the expert, but I've heard, so for example, crop farm could be an indicator. It attracts wild birds. So that could be an indicator risk factor. So we have expanded the data we are collecting. Another thing we are doing, we heard backyard poultry also contributes to an outbreak, and no kind of detailed information was available. So we are looking at satellite images to see if we can identify the backyard poultry and then add it to the value of farm density in a region. So because farm density is an important risk factor, the more dense the farms are and close to each other, the outbreak obviously is stronger. So if we can identify additional farms, backyard poultries, and then add it to the farm density and make that metric more accurate, that may give us a better prediction for outbreaks. So that was one step. And as I mentioned, it's extremely time consuming because you have to collect data, pre-process, and analyze that information. Next slide. Yeah, and then we expanded our decision support system. You saw this diagram in the previous one, and then over here, again, social media data, we have added more kind of these data sources. Interestingly, we this time before Elon Musk go crazy and close a collection of Twitter data, we were able to collect a large amount of Twitter data before he closes. Now it's extremely expensive for research. We cannot afford collecting that information. We collected Google Trend, other online sources. Again, this time even stronger. It has shown that almost everywhere in Canada, because and even US, we are able to predict avian influenza activities before it is officially reported. So because we can monitor, and then we have seen there is quite a strong trend between when people become active online, especially during the first wave, and the disease outbreak itself when it is officially confirmed and reported. So that's what I should mention. So people know there is something going on, and maybe investigation is currently going on, and then it takes several weeks, but we are able to detect that earlier. And we have collected farm data thanks to CFIA. We didn't have that information, but it's not on farm, for example, video or animal activity or sound or environment in the barn, but some little bit more specific farm data was collected. Has been collected. CFIA provided us anonymized data, and also special temporal data as usual. But this time we engaged end users. And if we go next, yes. So these are very technical kind of activities that we work on data to how to make it trustworthy, how to anonymize data, generate synthetic data. So there is a lot of effort, as I mentioned, in terms of pre-processing in the back end. Next slide. Yeah, so I don't think this is too technical. I don't think this would be of interest if we can. Yep. So in terms of models, I don't know how interested you are to know about the models. We are quite flexible in terms of the models that we are using in this decision support system. We use very basic if needed. So because human brain, we usually make decisions based on small data. If we want to go out, or when we are going to leave. We know the distance, so we make a decision given the traffic in terms of when we need to leave. So we collect our brain uses very small data points. But when you think about it, those data points come from big data. If let's say we see a stop sign and we stop, although it's based on very few data points that we make that decision, but our brain has been trained to recognize the stop sign and stop. So that's big data that we have analyzed long time ago, and we have that information stored somewhere. So what we are doing is similar concept. So I mentioned about backyard poultry recognition, identification. So we train a model to identify backyard poultry farms, but then our algorithm has been trained. So if we feed another satellite image, it can immediately, hopefully with a high accuracy, this is still research that's currently going on, and so basically it can immediately in a short period of time identify the backyard poultry and add that number to the farm density a metric that we have. So again, we use very sophisticated algorithms such as large language models and very simple ones. But we also bring ethical considerations as we are building the AI algorithm. We make sure data is privacy preserving. We make sure data is not biased. We make sure, for example, misinformation is removed from the social media, and that's it. But so lots of consideration goes into building these algorithms. Next. So I have here some results from the social media data analysis. But Rachel, how much time do we have? Should we open the floor? Should I show two slides and then open the floor to questions, or?
Yeah, we can. How much longer is your presentation? We're not on a
Um,
super time crunch, so.
Oh, are we? Okay.
No, we're not. So
We
if
are
you
not.
want to,
Okay. So if you want, I can show some results and maybe some dashboards that I mean, the dash the visualization that has been included on our dashboard, and then maybe I can stop and take some questions. So basically, here's some results that we have on social media, and this result has been published. We are also working on predictive models using spatial temporal data. So I don't have those because they are they are being reviewed. But basically, for using social media, we this is the result for Twitter or X platform, and also for Google Trend. We also collected data from WAHIS, which is WHO, I mean, Canadian Food Inspection Agency reports outbreaks to WHO. Not all countries do that. For example, US doesn't always report, but they make the data available through USDA. So it's not that their data is not available. You can see over there it has written USDA, but it doesn't report to WAHIS. So we collected all that information. We cleaned Twitter data, and then we looked at the patterns and of activities online. Next slide. Yeah, so these are the very, I do believe I have images. If you go to the next slide, maybe I have images. Yeah, this is much better. So basically what we did, first of all, we looked at the country. So when you have access to that information, and for X, it was a little bit more challenging because people don't report their location. So we have to find awkward ways to get some locations. I mean, some sophisticated approaches to uh, extract the location of the users, and in some cases we can't, so we cannot use that information for this analysis. But we looked at different countries, we looked at different provinces activities over time. We So as you see at the bottom image, um, you see some dark red means that those areas have been quite active in terms of using online tools to either report or post. Uh, as you can see, US has been quite active. I mean, lots of information online. For Canada, again, one of the provinces is darker than the other ones. Maybe because the outbreak was stronger, or maybe because the farmers associations were more active. What was interesting in this diagram? Some countries, they don't report, as I mentioned, the outbreaks, although it's a reportable disease and they have to report it to WHO. So when you look at WHO, that no information is available about those regions. But when you look at the map, you can see those countries have been quite active in Russia, China, or some of the Middle Eastern countries, which suggests that this could be a surveillance tool for health officials to understand, okay, what's going on in other regions, although their government are not cooperating or they are not reporting this type of disease. Um, and then we have been able, so if you go to the next slide, maybe the tables, oh no, sorry, going to the previous one, just wanted to briefly mention one thing, that, so our results show between 1 to 3 weeks in advance, we are able to detect an activity in a region. Again, that's quite useful because as a weak indicator, we are not suggesting that social media or online tools are very strong indicators, but it is quite helpful because then health officials, they can monitor the environment online, and also they can make a decision, okay, some anomalies, some uncommon behavior or activities are happening in a region, and so they can decide what to do, and what actions, or maybe inquire about what's happening in that region. And also with our tool, we are able to, especially for X, we built a tool to identify misinformation. Again, this is quite useful because health officials can use that information. So what kind of inaccurate information is going around, and we can even identify those what we call bots, robots, online robots, online chatbots, to be more exact. we can identify those as well with a high accuracy, especially we did that for COVID. Again, government health officials can look at that region, look at that information, and educate people about about educate them about misinformation, just make them informed that what kind of misinformation is going around, and kind of guide people, the emergency farmers, producers, or whoever public about the issue to make sure they have the right access to the right information rather than being misled by misinformation. So there are many different ways that these tools could be used. Sorry, next slide. And so predictive modeling, which is of interest by CFIA, quite a bit in demand, and I know they're working on it as well. It's quite a hot topic. So knowing what's going on right now is interesting, and it's very important. Knowing what happened historically, what we call descriptive analysis, that's also interesting. But we want to be able to use that information to predict future outbreaks. I mean, that's our goal. And that's the goal for emergency responders, decision makers. So then with that goal in mind, as we started collecting spatial temporal data, as I mentioned, in Indonesia, we showed 82% accuracy. We can predict an outbreak in a region within a week or two, or sometimes even sooner. So basically, we look at, for example, how dense are the farms over there. We are hoping to maybe look at the road density in that area, how connected the roads are, similar concepts to COVID, as people were able to move around more, and or social distancing. We look at the farm density. Maybe one of my students found that backyard poultry contributes to one of the recent outbreaks, H5N5, I think, or maybe is it? Yeah. So anyway, so we can find correlations. So we look at farm density, we look at land cover, we look at wild bird, we look at population, all of those indicators, historical data, and wetlands, absolutely critical, the number of wetlands and distance to water. So many of those factors, and we combine them together. Small group of combination, large group of all factors. When you have the data, it's fun to integrate them and look at the accuracy of the predictions. And accuracy of the predictions are validated based on historical data. So we don't do it on new outbreaks. We build these tools on historical outbreaks and validate it, and all of that. But also going back to ethical AI concept or ethical data analysis. So we predict, for example, with 95% accuracy, this region will be impacted in the next 2 weeks. But then the subject matter experts want to know how AI has made that decision. I mean, we call it explainable AI or interpretable AI. This is a huge topic right now, especially because of the regulations in Europe. And so we have made our algorithms, and we have designed the decision support system architecture with the mindset that it has to be explainable. So we are able to say, for example, the factors contributed to the decision or prediction of this model were, first one was farm density in that region. Second was the number of wetland in that area. So our algorithms are able to bring that transparency to the end user. This one. Yeah, so this is on more information on the backyard poultry, as I mentioned. So we have collected some data from some of the established organizations. We have paid and collected some kind of land cover data, basically satellite images from Canada and US. We have used CFIA data to annotate that because, AI algorithms learn from human annotation to identify objects. and then we have fed that to a deep learning algorithm to to identify and see with what level of accuracy we are able to identify backyard poultry farms. Next one. So this is on collecting high quality data. As I mentioned, data doesn't have definition, so we are collecting definition for the data. We can go to the next slide. This is our website, which it has the dashboard. If you are interested to have a look, I can share the website. We also have definition of the data that we are currently using. Next slide. Yeah. So within, I'm not sure if there's an interest to talk about governance. So Rachel, if you have time, I can go over this slides quickly, or I can stop.
So trying to get to my mute button here. Yeah, if you want to continue, you're welcome to. Yeah.
Yeah, so yeah, I just want to quickly say, as part of this project and another project that we are working on, so as I mentioned, we are looking into governance and data sharing and confidentiality. So we have built toolboxes, which we are hoping that producers can help test those toolboxes for us. So we have created kind of guidelines for privacy, protecting farmers' privacy, and also both for ag tech providers in terms of what features they can add in to their the technologies, and also for farmers in terms of how they can protect their privacy. In the tool that we are building for the decision support system, although this tool would, for now, it's aimed for emergency responders, but we are also using some of those recommendations that we have included in the toolbox to we use it to protect farmers' data, to anonymize farmers' data. For example, the poultry backyard poultry we identify, we don't use the raw data, the raw image of the kind of the backyard poultry. We try to use best practices to just use part of those images, but part of indicators or metrics that are collected from those images to analyze data. So that's in terms of privacy enhancing and confidentiality enhancing methods. We have also conducted, and the result will be out soon, a survey. We have interviewed 25, around 30 farmers around data sharing. So we have collected 210 data agreements. We have presented. We have kind of took some parts of that. Those data agreements, and we have spoken with farmers to understand what their concerns are around using their farm data. Again, that was extremely important to us to understand, because these decision support system tools, they store data over time. And if somebody has concerns around data sharing and data confidentiality, we had to know how we can store that data. Because again, in terms of technology, there are solutions that we can anonymize and protect data, but we wanted to know what farmers really need, or what their needs are. So that was something we wanted to know. So we have interviewed farmers, poultry producers specifically on this, and we are also interested to expand these interviews if there is an interest within this group or anywhere else to be part of this study, just to understand what we can do to enhance, to protect data, farmers' data, to make sure that we understand their needs and embed it into these systems, and also to build trust between farmers and what we do, and also the tools that we build, or maybe in the future will be built by technology providers. So we have conducted, all sort of looked at regulations, looked at best practices, looked at what Europe is currently doing, and we have also spoken with farmers. So maybe we can skip some of these slides, and I have to see. Sorry, I cannot see it. Yeah, okay. If we go to the last one, and I conclude there, the one before. Sorry, two before. Yeah, here. So what we are doing with this, We have engaged a very large group of collaborators from FAO, some people, because avian influenza is a huge topic. So we have collaborators from FAO, we have INRA in France, our colleagues in Denmark and collaborators and Netherlands, they have shown interest and they are quite actively working on this. Some of my colleagues who are creating vaccine, I'm not sure if you've heard, but Canada is considering vaccination of poultry animals. I mean, just they are considering. I don't believe a firm decision has been, or maybe I'm not aware of. But anyway, lots of activities currently going on. We are connected nationally and internationally. We will continue working with our colleagues, collecting more data sources, and then bringing that into risk assessment and then building models. We will continue also working with the subject matter, so lots of human engagement. We will also continue on the governance aspect to understand what can be done and what are the new methods that are being developed to make the tools like this more ethical and usable. And we are hoping to share, I mean, we definitely share what we learned throughout the process in terms of building decision support tools for clinical dashboards. It's a very limited study in these areas, what needs to be built and tested. Um, and then we want to test our DSS in different regions, with data from different regions to see how useful it is. But it's extremely important to work with the end users, whether from the governance aspect or from governance or from kind of data collection and decision making point of view. So the next step, which I'm envisioning, there's a concept called digital twinning. So digital twin is just, I don't know how familiar you are with augmented reality, but now technology is moving towards, especially for agriculture, testing what if scenarios. So right now we cannot test what if scenarios. We can just say, this is the data, this is a historical outbreak information, and that's it. So this is how we are predicting. Just imagine a world that emergency responders, producers, everybody, they can sit behind a computer with a very nice visualization and they can say, oh, okay, what if there were 10 more farms close to us? What if we were closing to the body of water or 10 more or wetlands? How would the nature of this outbreak and then the speed of this outbreak will change in terms of spread? Or we had these many more animals, or so these what if scenarios at this point with the data that we have, we cannot test. But if we collect data from all different sources that we are currently doing, especially having access to farm data, maybe some of you have sensors in your farms, or that you have cameras installed. If we can bring that information into this whole ecosystem of decision support system, maybe in 5 years, we can build this digital twin of the real world physical environment and then test what if scenarios and visualize it and see what happens. So it takes us a little bit closer to the gaming industry, because you can hire students or experts with game background and they can build the interface for you. That it shows, for example, how many animals may die if we change some parameters. Basically, the agriculture industry is moving gradually towards that, maybe for crop and some other sectors a little bit faster because they have more sensor data. But this is also the future. I envision maybe in a few years we can start doing this type of research. So with that, I want to thank you for your time and also for listening. I hope the things that I said make sense to you. And please let me know if you have any questions or comments. Thank you very much, Rachel. And I apologize for this unexpected change last minute.
No worries. Thank you, Rozita. That presentation was great with a lot of interesting information. I don't know if I have a question, but I don't know if it's going to be a good question or not. But do you think that once this kind of data and like research is like kind of finalized and figured out that there would be an opportunity to expand it to like other communicable diseases impacting other livestock and animals too, outside of avian influenza?
Oh, 100%. I think some of my colleagues are working on similar ideas for other animals and other type of disease. Uh, from technology perspective, yes, everything I mentioned about ethical side and the AI and decision support system, yes. But obviously, in terms of the actual application, everything that I mentioned about data and involvement of the end users and what type of data, it has to be repeated from scratch.
Right.
But the technology can be reused for sure.
I'm interested. Right. Are there any other questions from anyone? Sounds like no. Okay, thank you very much, Rosita, for all your information and your sharing your expert insights and knowledge with us today. And then this session has been recorded, so it will be shared on our YouTube channel as well and through our social medias for anybody who wasn't able to attend today. And I hope this information sparks some ideas on how AI can be implemented in the future of that on farms and for detecting um, AI avian influenza. Uh, that'll
Yes.
be a great tool, future reference. Yeah.
Yeah.
Okay, so
Yeah.
thank you for your time today, Rosita, and thank you for everybody else who's attended. And have a great rest of your day.
Okay. Thank you very much, Rachel, for the
Thank
invitation.
you.
Thank you. Bye.
Bye.